everyone. Let us try to explore that how can we implement the naive Bayes theorem with the help of Python library, that is sklearn. So let us begin here. So naive Bayes implementation we are looking at. So let us import the necessary libraries. And initially I'll just import pandas as pd, and that's it. And let me also import the dataset which we are using. It is social networks dataset, and I will load it from my downloads folder. So this is social network add dataset, and I have loaded it over here. Let me copy the path. I have copied the path from here, and now let us proceed. So now data set is equal to pd dot read underscore csv, pd dot read csv, and here let me put the path, and let us see that what sort of data do we have here. So here we have 400 rows with 5 columns, and the columns are user ID, gender, age, estimated salary, purchased. So these are the columns we have. Now we can transform this data in the form of x and y, and that basically means we can have this data in the form of the input and the output. So we will have x is equal to, normally we write capital X is equal to data set dot iloc, and with the help of iloc I'll be taking up all the rows, but from column I'll be taking up only the second and third column because they are more relevant. Dot valus values. So this is what is going to bring data into X, and let us see what sort of data do we get. So we are getting only the second and third, that is age and estimated salary. So this is what we are getting. And then I would like to get in y will have the outputs. So let us have y over here. So y is equal to, we will take up data set dot iloc, and here all the rows we will have, and fourth column, that's it. So that is what will be in y. And now we have x and y with us. We can go ahead, and we can try to organize the data into training and testing format. So let us try to do that part as well. For that I will require another library, which is from sklearn.model model underscore selec selection, import train train test split. So this is what I need, and with the help of this particular library I will divide the data into train and test samples. Now let us use x underscore train train comma, we have x underscore tst test, then we have y underscore train train comma y underscore tst test. Okay, so is equal to train train underscore tst test underscore split split, and inside train test split what I will do is x comma y we will put, and tst test underscore size test size we will put 25%. So 25% of the data will be of test size. Okay, so somewhere double equal to is, okay, so here basically instead of comma I had put a dot. It says that inconsistent number of samples. Okay, so this y needs to be capital, and therefore it was giving in that particular manner. Okay, that's done. So we have x train, x test, y train, and y test. We have transformed the data into split the data into training and testing. Now let us scale the data. Scale. So for scaling up from sklearn dot pre-processing import standard standard scalar. So with the help of this standard scalar, we will transform the data. So x train is equal to sc dot, we will use fit underscore transform. So this fit transform will learn from this data and transform it, that means resize it in very simple terms, x train train. So with the help of x train only it will, okay. And before that I will just create sc is equal to standard standard scalar. So I need to create an object of standard scalar which is going to help me out with scaling up the values. So I have scaled the values of x train. For x test also sc dot fit fit transform I'll do. So fit transform, and here I'll put x underscore tst x test. So it is basically, yeah, so x test is not defined. That's the reason, because x needs to be capital. So now the pre-processing part we have done. Now we can actually move to build the model. So for building the model, let us do from skler and sklearn.naive naive yes naive bias. So from sklearn dot naive bias import gaussian Gaussian nb. Okay, so let us import this. So gnb is equal to gassu, so Gaussian nb. So we'll create the object of Gaussian nb. This is the naive bias model, and we will train it. So gnb dot fit, and I'll be passing x underscore train data into it. And because it also requires the y train, so I'm giving y underscore train train. So it is learning from the training data set, and now once it has learned, I can use gnb dot predict. So pred. So this predict function will only take x underscore test, and it is going to give the output. So this output, let me store this output into a variable. So I'll name it as y underscore pred is equal to this. And now we can check that how much similarity or similar they are, y pred and y observed. So here from, so we are doing evaluation, so evaluate and evaluation. So from sklearn learn dot metrics, from sklearn dot metrics import accuracy by accuracy score. So we'll get accuracy score, and we will also get confusion matrix, confusion confusion matrix. Okay, so that also, so we have accuracy score and confusion matrix, two things we have taken. Now let us print the accuracy. So print accuracy, accuracy by accuracy. So what is the accuracy? Accuracy is accurax, we'll call the function, and with the help of that function we'll compute. So accuracy score, here we need to put the y underscore tst test and y underscore pred pred. So both of the outputs I need to put, and you can see the accuracy is 89% here. So 89% on this particular data set. And if I try to construct a confusion matrix, so confusion matrix. So this confusion matrix tells us about true positive and false negative, true negative and false positive. So it tells about that. So confusion matrix, let me create that, y underscore test comma y underscore pred pred. And let's see what is the kind of confusion matrix does it create. So here cf, let me print cf, and you can see that we have here 68 3 29. So 60 and 29 are correct, 8 and 3 are the incorrect predictions, and therefore the accuracy has got reduced to 0.89, that is 89%. So this is how we have implemented the code for naive Bayes algorithm, and we have checked the accuracy also. I hope you were able to understand this. Type this, try to understand, and try to work on more data sets. Thank you very much.